Hello everyone, in this video I'm going to explain on the topic goodness of fit test, and that the chi-square test for exponential distribution, that is the equal probability. If you want to see the problems on chi-square test for Poisson distribution, you can see the YouTube link in the description below. Now let us see the procedure for chi-square test for exponential distribution. The first step is to determine the probability where p equal to 1 divided by k, where k is the interval. So interval is nothing but how many class intervals be divided. So that we are going to count it as the number of intervals. In the step 2, determine the mean lambda equal to 1 divided by x bar. We have a formula for x bar equal to summation of I equal to 0 to n xi divided by n. It's nothing but we have to count all the random numbers whatever they are given, that is nothing but xi, and total number of the random numbers what they are given in the question. This is about the step 2. And in the step 3, compute the class interval. We have a formula for that. A equal to minus 1 divided by lambda natural log of 1 minus I into p, where I equal to 0, 1, 2, 3 till k. In the step 4, compute the expected frequency, that is ei equal to n divided by k, where n is equal to sum of the sample data, k equal to the intervals, number of intervals. In the step 5, compute the chi-square test. We have a formula for chi-square test, that is x naught square equal to summation of I equal to 0 to n oi minus ei whole square divided by ei. This is the formula what we have for chi-square test. And in the step 6, we are going to obtain a critical value using a chi-square table. So that is x alpha comma k minus s minus 1 square. Let us see the chi-square table to calculate the critical value. In this x-axis is called as alpha values what are given, and in the y-axis that is nothing but k minus s minus 1 value. Using this table we are going to calculate the critical value here in the step 6. And in the step 7, check the hypothesis or null hypothesis, whether the hypothesis is accepted or not accepted. What is the condition for accepting the hypothesis is x naught square, the value what we computed in the step 5, that value, if it is lesser than the critical value, then we are going to accept the hypothesis, or else we are going to reject it. That is, if x naught square is greater than x alpha comma k minus s minus 1 square, then we are going to reject the hypothesis. This is about the procedure for chi-square test for exponential distribution. Now let us see one problem based on this. The problem what they are given here is apply goodness of fit test to check whether the random number are uniformly distributed over the interval 0, 1 using an equal probability. Use alpha equal to 0.05 and the interval k equal to 8 to check whether the given sample data are accepted or rejected. This is the given sample data they are given, and alpha value is given as 0.05 and the interval that is uniformly distributed over 0, 1 and the interval they are given it is k equal to 8. So now let us see how to solve this problem using a goodness of fit test. And here is the solution. Given k equal to 8, that is the interval they are given k equal to 8 and the alpha value they are given, that is 0.05. Now what is the step 1? We have to compute that mean value or the probability you have to compute. So here I am going to compute the mean value, that is lambda equal to 1 divided by x bar, and where x bar equal to summation of xi divided by n, that is summation of xi is nothing but we have to add all the random numbers what they are given in the table. If I add all the random numbers what they are given in the table, I got this answer, that is 594.674 divided by total number of random numbers. Count how many number of random numbers are there, that is we have a 50 random numbers over here, so that is nothing but divided by n. So divided by n, that is equal to 50. So we are going to get a mean value, that is 11.894. So lambda value is nothing but lambda is equal to 1 divided by 11.894, that is x bar value, that is the mean value we got, 11.894. So x bar, substitute here 1 divided by 11.894, we are going to get a value for the lambda, that is 0.084. And in step 2, compute the class intervals. We have to compute the class intervals, and for that we have to calculate the first probability. Probability equal to 1 divided by k is equal to 1 divided by 8. K is nothing but the interval. 8, they are given the value, k value, that is 8 they are given. So substitute 1 divided by 8. So you are going to get 0.125. And we have a formula to compute the class interval, that is A equal to minus 1 divided by lambda natural log of 1 minus I into P. So we know the value of lambda in the step 1 we calculated, substitute it over here, and the P value also we know here, the probability is 0.125. So substitute in this formula and we have to calculate the 8 values, that is A0 to A8. 9 values we have to calculate here. So where I equal to 0 to 8 we have to calculate. So here lambda value is equal to 0.084. In the step 1 we got that, and the p value here is 0.125. So A0, first is I value is 0. So A0, AI is equal to 0, that is I value is 0. Substitute in the place of I, substitute 0. Minus 1 divided by lambda natural log of 1 minus I value is 0 into P. So minus 1 divided by lambda value is 0.084. Natural log of 1 minus 0 into P is nothing but it will become the 0. So natural log of 1. So natural log of 1 value, it's 0. So multiply the 0 with anything. So you are going to get the first value as 0 itself. That is A0 as 0. Now calculate the A1. Minus 1 divided by lambda natural log of 1 minus 1. In the place of I am going to substitute here 1 into P. And the lambda value we know that 0.084. So natural log of 1 minus 1 into P value 0.125. So you are going to get, if I calculate all these values, we are going to get a negative value, that is minus 1.589. So minus negative value, minus into already 1 minus is here. So minus into minus, it will become plus 1.589. This is about how you are going to calculate the value of A1. Same like that, here you are going to calculate A2 till A8. Now calculate the value of A2. If I calculate the value of A2, in the place of I am going to substitute 2, lambda is 0.084 and the p value is 0.125. If I substitute all this and calculate the value, so I am going to get the value of 3.425. Now same like that, you are going to calculate the value of A3. Minus 1 divided by lambda, lambda value is 0.084. Natural log of 1 minus I value is 3 into P, P value is 0.125. If I calculate all this, you are going to get a value A3 5.595 and A4 minus 1, same. If I calculate the value of A4, you are going to get a value 8.252. And the value of A5, if I calculate the value of A5, the value of A5, you are going to get a value of A5. A5 is nothing but here 11.677. So this is the value of A5 we are going to get, and the A6 value 16.504 and A7 is 24.755, and here the A8 value you are going to get a value is infinity. So we calculated now the value from A0 to A8 value. All the 9 values we calculated over here. And now let us see the class interval. How the class interval is divided. 1, 2, 3, 4, 5, 6, 7, 8 values, 8 intervals, that is k equal to 8 they are given. So here we are 8 intervals is divided. How we are divided these 8 intervals is, now here we calculated the class intervals, the values from 0. The first interval lies from 0 to 1.589 and from 1.590 to 3.425 is the second interval. Third interval is 3.426 to 5.595. Again, the next interval from the next value, that is 5.596 to 8.252. So now let us see, like this we are divided, we got the 8 intervals over here, that is from 0 to 1.589 and from 1.590, that is next value, that is 589. After 589, 590 you are going to get to 3.420. Next value is 3.426 to 5.598. Like this we calculated all the 8 intervals in using the formula here. So till infinity, from 0 to infinity. Now OI is nothing but the observed frequency. How we are going to calculate the observed frequency is, how many number of random numbers which lies between 0.0 to 1.589. How many values are there in the given table? We have to count that values. Now let us count how many values are there in the table. The value which lies from 0 to 1.589. Let us count it. How many values are there here? So here the first value is 0.062 and the next value in this row is 0.021, 0.013 and 0.123. In the next row, so 1.192 and here the next value 0.141 and 0.433. The value which lies from 0 to 1.589. So in the third row, that is 0.091, again 0.941 and 0.878. And in the fourth row we have a value that is 0.624 and the next value is 0.590 and 0.300, 0.002, 0.543 and the next value in the next row 1.005 and 1.147 and 0.219 and here 1.008. These many values are there. Now let me count how many values we got here. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 values we got. The value which lies from 0 to 1.589. So enter the value over here 19. Now in the next class interval is 1.590 to 3.425. Now let me count in the table. Now if I want to count, mark it in a different way so that you can easily identify which are the numbers we counted in the next interval. That is from the value from 1.590 to 3.425. Now in the first row we have 3.081. I am going to mark like this so I can easily identify. The next value 1.961 and the next value is 3.027. In the next row we don't have any values which lies in that interval and in the next row we have 2.663 and in the next value is 3.371 and the next value is 2.157 and the next value that what we have in the next row is 3.148 and the next value is 1.928 and the next value which lies over in that interval is 3.27217 and the next value 2.336. Now let me count how many values we got. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 10 values we got. So enter the value over here, 10 values. In the next interval we have to count, that is from 3.4 to 5.5. So in the table, here is the table. So the third interval, the value lies here is in the first row, we don't have any value. In the second row I have, that is 5.009, and in the third row we don't have any values, and in the fourth row I have 5.380, and in the fifth row I have a value 4.562. So only 3 values we got. So enter it here, that is 3. Now the next value, that is which lies from 5.956, sorry, this is 5.596. So how many values are there? We have to count it. So go to the table. Here in the first row, 5.845 lies in that interval, and 6.505 lies in that interval. Again 6.769 lies in that interval, 7.579 and 7.078 and 7.004. These values which lies in that interval, that is 1, 2, 3, 4, 5 and 6. 6 values are there. So let me enter it over here, the value 6. In the next interval, that is from 8 to 11. So let me count in the table. We got only one value, that is 9.003. This is the only one value I have in the table. So I'll enter that value over here. The next interval, let me count, that is 14.38. I am going to get only one, that is 14.38. So only one value, enter it over here. Again in this, the next interval from the 16 to 24. So from 16 to 24 I am having only one value, that is here 24.420. So this is the only one value I have, the value which lies in this interval, only one. And in the next interval, that is from 24 to infinity, whatever the remaining values we have, let me count all the values. So 1, 2, 3, 4, 5, 6. We have a value from 16 to 24. So here I'm very sorry that I did a mistake here. This is, we have to count it properly. So now let me count it over here. How many values we have? Let me count the value again for 16 to the 24 interval. I'm counting it again. That is the one value, that is 24.420 I did previously, and now I'm continuing with the same thing. That is the next value is 18.387 and the value, and 17.967 is another value, and one more value is 23.960. These are the 4 values we got for this interval. So I'm going to enter the value 4 over here, and for this remaining, how many values we have to count it, that is 1, 2, 3, 4, 5 and 6. 6 values are there. So let me count it once again, that is 1, and 2, 3, 4, 5 and 6. 6 values. So I got the value over here 6. See, if you are marking like this, then you will come to know which are the numbers you counted, which are the numbers you left, which number you want to recount it again, in which interval you did the mistakes, all those things you will come to know. So please mark each and every step it in a different way so that you can easily identify where you did a mistake. So now observed frequency, if whatever we counted, whether it's correct or not, we can check it over here. If I add all these values, we must get a value. It's 50. Why? Because 50 random numbers they are given. So we are going to get a value of 50. Now EI value, that is the expected value. Expected value is nothing but n divided by k. N is nothing but the 50 values. 50 divided by k. K they are given. It's an 8 interval. So 50 divided by 8. So it's nothing but 6.25. 50 divided by 8. So it's a common 6.25. Again here 6.25. For all the values you are going to get a same interval 6.25 itself. Next is OI minus EI. OI minus EI, that is 19 minus 6.25. You are going to get a value that is nothing but 12.75. And again 10 minus 6.25, that is 3.75. The next value 3 minus 6.25, you are going to get a value that is the negative value minus 3.25. Here 6 minus 6.25. So you are going to get a value of minus 0.25. Again 1 minus 6.25 minus 5.25. Again 1 minus 6.25. Again minus 5.25. Again 4 minus 6.25. So you are going to get a value that is minus 2.25. Again the next value 6 minus 6.25, that is minus 0.25. So OI minus EI whole square, whenever you are doing a negative value square, minus into minus, it will become plus. All the negative values you are going to get a value of plus. So 12.75 whole square, you are going to get a value 162.563. Again 3.75 whole square, it is nothing but 14.063. Again 3.25 value you are going to get 10.563. Again minus 0.25, 0.0625. Again 5.525 value you are going to get 27.563. Again 5.25 is there, so 27.563 itself. 2.25 value, it's nothing but 5.0623. Again minus 0.25, minus into minus, it will become plus 0.063 is the OI minus EI whole square. Now we have to calculate the chi-square test using this formula, that is OI minus EI square. OI minus EI whole square we calculated here, and the value of EI we calculated here. Value of EI is nothing but 6.25 for all the 8 intervals. So 162.563 divided by 6.25, you are going to get a value 26.01, and 14.063 divided by 6.25, 2.25, and the next value you are going to get 1.69, and the next value is 0.01. Next value you have 4.41. Again you are going to get the same value here because we have 27.563 divided by 6.25. So 4.41 itself. Again 5.0623 divided by 6.25 is 0.81. Again here 0.063 divided by 6.25, you are going to get a value 0.01. So now if I add all these values, that is the summation of I equal to 0 to n, all these values if I add, I'm going to get a value that is 39.60. This is the value what we calculated using a chi-square formula. Now we are going to see whether the hypothesis is accepted or not. For this, we have to calculate the critical value. How we are going to calculate the critical value? Now here we have to calculate the critical value, that is x alpha comma k minus s minus 1 square, that is nothing but x alpha value it's given in the question, that is 0.05, and k value also given 8, and s is nothing but, for the goodness of it, is in the chi-square test formula it is always 1. So 1 minus 1, that is equal to x square 0.05 comma 6, that is 8 minus 1 minus 1, that is 6. So let us see the value in the table, that is 0.05 comma 6. So here is the table 0.05, the alpha value is here, and the 6 here it is 6. So in this row if I see, that is 12.59 is there. So enter the value over here 12.59 or 12.6. So I entered 12.6. If you want, you can write it over here 59 itself. So 12.59 is the critical value. And check whether the random numbers or whether it is uniformly distributed or not. We have to compare the value x naught square what we got, that is 39.60, which is greater than 12.59. So 12.59, whatever we calculated, that value is greater than the critical value. So the random numbers are rejected here. It is not uniformly distributed. So the hypothesis is rejected. Thank you everyone. Subscribe to the channel to watch the more videos related to system simulation and modeling subject. And you can see the end cards over here for different problems. Subscribe to the channel. Thank you everyone.